In this video, we're going to work example problems related to the average value of a function. In addition, we're also going to work problems related to the mean value theorem for integration, which is directly associated with the average value of a function. All right, so let's get started. Find the average value of the function on the given interval. So the idea is we've got this function in a given interval of this function, and we want to know what's the average value of the function over this interval. In the previous video, we went through the theory of how the average value of a function over an interval is defined. So I'm not going to get into that here, but f average is equal to 1 over b minus a times the integral from a to b f of x dx. That's it. So this is b minus a, it's 2 minus 1, that's 3. So 1 over 3, and then the integral from minus 1 to 2, 3x squared plus 8x dx. Okay, so now we just need to evaluate this definite integral. We've got just x cubed plus 4x squared. Evaluate this from minus 1 to 2. Okay. So this is, plugging in 2, you get 8 plus 16 minus, and then minus 1 plus 4. So 24 minus 1 plus 4 is 3. So 1/3 times 21, 7. That's it. That's the average value of the function over this interval. Okay, same question, just a different function, different interval. So f average is 1 over b minus a, so pi over 2 minus pi over 2, that's just going to be pi. So 1 over pi, and then minus pi over 2 to pi over 2, 3 cosine x dx, so we can take out that 3. And we're just left with cosine x dx. Cosine x is an even function. And so since we're going from minus a to a, we can take out a 2. So now we've got 6 over pi, and then evaluate this from 0 to pi over 2. Okay, so what we've got is sine of x evaluated from 0 to pi over 2. So this is 6 over pi. Sine of pi over 2 is 1. Sine of 0 is 0. So this is 6 over pi. Okay, so the average value of f of t, 1 over b minus a, so that's 1 over pi over 2, that's 2 over pi, and then integrate from 0 to pi over 2, e to the sine of t cosine t dt. Okay, so we can say that u is equal to sine of t, therefore du is equal to cosine t dt. So we've got f average is equal to 2 over pi. When u is equal to 0, or when t is equal to 0, u is equal to 0. When t is equal to pi over 2, u is equal to 1. And then we've got e to the u du. Okay, So this is 2 over pi e to the u evaluated from 0 to 1. So this is 2 over pi e minus 1. And, you know, that's we can leave it like that. That's it. Okay, so F average 1 over b minus a is 1 over pi, and then we're integrating from 0 to pi cosine to the fourth of x sine of x dx. So if we say u is equal to cosine of x, then du is equal to minus sine of x dx. So minus du is equal to sine of x dx. So we've got when x is equal to 0, u is equal to 1. When x is equal to pi, u is equal to minus 1. And then we've got u to the fourth. And then sine of x dx is minus du. So put a minus here and then like that. So we've got minus 1 over pi, 1/5 u to the fifth, from 1 to minus 1. Okay, minus 1 over pi. So we start with minus 1, so that's minus 1/5 minus 1/5. So minus 1 over pi minus 1/5 minus 1/5 is minus 2/5. So 2 over 5 pi. All right, for these problems, we're gonna incorporate the mean value theorem for integration. So we're gonna find the average value of the function in the given interval, just like we just did. But then from there, we're gonna find this value c such that f of average is equal to f of c. That's what the mean value theorem of integration is all about, that if you've got a continuous function on some interval, then there will be at least one value, c, between a and b to where f of average is equal to the function evaluated at c, right? Then part c is based on the geometric interpretation of the mean value theorem of integration, but you can only really use this geometric interpretation if the function is positive over the interval. But so it says, sketch the graph of f in a rectangle whose area is the same as the area under the graph of f. So we'll do that as well. So first step is just find the f average, just like we just did. So b minus a is 3. So 1 over 3, going from 2 to 5, x minus 3 squared dx. So if we say u is equal to x minus 3, then du is equal to dx. So f average is 1/3. When x is equal to 2, u is equal to minus 1. When x is equal to 5, u is equal to 2. U squared du. So we've got 1/3 u cubed evaluated from minus 1 to 2. So 1/3, and then 2 cubed is 8, so 8/3 minus, and then minus 1/3. So 1/3, 8/3 plus 1/3. That's 9/3. 9/3 is 3. 3 times 1/3 is 1. So f average is equal to 1. All right, find c such that f average is equal to f of c. So the whole idea is, for the mean value theorem, is that you've got this f of c is equal to the f average, which we know is b minus a, right? That's what the theorem says, assuming that the function is continuous over the interval we're working with. Well, we know, okay, we just calculated this. This is 1. So what's the question asking us? Find this c. Well, so all we need to do is this. C minus 3 squared is equal to 1, right? It's the function evaluated at this number c is going to be equal to 1. So where does x minus 3 squared equal 1? C minus 3 is equal to plus or minus 1. C is equal to 3 plus or minus 1. So we've got C is equal to 4 and C is equal to 2. And both are within the interval. So there's 2 C's. C is equal to 4 and C is equal to 2. And again, what is that saying? It's just saying that the average value of the function over the interval from 2 to 5 is equal to 1. And then there's 2 values within the interval from 2 to 5 where if you plug in those x values, you get the function is equal to 1. F of c or f of 2 and f of 4. All right, now sketch the graph of f in a rectangle whose area is the same as the area under the graph of f. So this is the geometric interpretation of the mean value theorem of integration, which we can only really do this when the function is positive over the interval, and this one is. So the idea is, the geometric interpretation is that, so the mean value theorem states that you have f of c is equal to this f average. And so all the geometric interpretation is saying is that if we multiply this by b minus a, then what are we left with? We've got f of c times b minus a is equal to, so what is this saying? The area under the curve from A to B is equal to this rectangle here that's defined by just the interval width times the f of c height. But you can see that you can only really look at it this way for functions that are positive, because otherwise you get this net area that includes like a negative area being subtracted, so it won't really work out that way unless f of x is positive over the whole interval. And so, but it is positive from 2 to 5, so we can see that. So this is f of 2 is equal to 1, f of 4 is equal to 1. So the idea is we do this all the way to 5, from 2 to 5 over the entire interval. We have this rectangle. So it's f of c, so it could be f of 2 or f of 4, doesn't matter, times the interval width. And that's the area of this rectangle. That area is equal to this area. That's the idea. That's like a geometric interpretation of the mean value theorem. All right, same type of problem. Let's start by getting f average. So this is going to be 1 over pi, that's b minus a, 0 to pi, 2 sine of x minus sine 2x dx. So this is 1 over pi, and then 0 to pi, we can take a 2 out here, sine x dx, minus 0 to pi sine 2x dx. Okay, so this is 1 over pi. This would be minus 2 cosine x, and then take this from 0 to pi, and then minus, so we could do a substitution here, but if we think about it, the derivative of sine, the derivative of cosine of 2x is what? Minus sine of 2x times 2. So we want to say is minus 1/2 cosine 2x. You see, the derivative of cosine 2x is minus sine of 2x times 2. So the times 2 gets rid of the 1/2, and the minus gets rid of the minus here, so we're left with sine of 2x. Okay, and evaluate this from 0 to pi. And then, okay, like that. So we've got 1 over pi minus 2. Okay, cosine of pi is minus 1 minus cosine of 0 is 1. Minus, so we can take out the 1/2 here, plus the minus 1/2, and then we've got cosine of 2 pi is 1 minus cosine of 0 is 1. Okay, so 1 over pi minus 1 is minus 2. Minus 2 times minus 2 is 4. And then this goes to 0, so it's 4 over pi. All right, so part B, if f of c is equal to 4 over pi, then what's c equal to? This is asking us to solve for c if 2 sine of c minus sine of 2c is equal to 4 over pi. So let's just go ahead and use our calculator here. So 2 times sine of c minus sine of 2 times c, store that as e. All right, now we want to solve for when e is equal to 4 over pi. We're solving for c. Okay, so you've got a bunch of values here, but we're just looking for the ones that are in the from 0 to pi. So no. There we go. So 1.24, put approximately 1.24 there's another one, 2.81. And that's it. So there's the values of c. And now if we sketch the graph, I mean, we don't even need these values of c, because all we're doing is the height of the rectangle is going to be 4 over pi, and it's going to go from 0 to pi. So this should be pi here. Yeah, let's see. The function evaluated at c is equal to pi is 0, okay? So that's pi. And so yeah, the function is always positive from 0 to pi. And the height is 4 over pi. What is 4 over pi? 1.27. That's not these values. These are the x values. At x is equal to 1.24, the height is 1.27. So, okay, each of these is 0.2. So this is 1.2, this is 1.4. So 1.2, 1.4, 1.3, so about right in there. Like that. And it comes down to here. That's the rectangle. If you evaluate this, what they're saying, this should be about 1.24. this x value, and this should be about 2.81. And the height would be 4 over pi. And the width is pi to 0. So that's the area of that rectangle is equal to what? Equal to the area under this curve from 0 to pi. All right, find the average value of the function, this function here from 0 to 8. And so we have negative regions here, but that's fine. The only issue with negative regions is it's going to be, you can't really use the geometric interpretation to try and get some intuition behind the average value. But it's still the same concept. It's just going to be the definite integral of this function from 0 to 8 divided by 8 minus 0. So we can start, what is the definite integral from 0 to 8? We're just going to get the areas, the net area. So it'll be this area plus this area minus this area. Okay, so this is the function f. So the definite integral from 0 to 8 of f dx is equal to, all right, 1/2 base times height. Base times height is 1 times 1, 1/2, so minus 1/2 plus, all right, so here we've got 1/2. Well, this should just be this should just be 2 times 1, right? 1/2, 1 times 1 is 1/2. 1/2 plus 1/2 is 1. So, okay, wait. The area of this is 2 times, yeah, this would, okay, the area would be 2 times 1 divided by 2. 2 times 1 divided by 2, which is the same as 1/2 plus 1/2. So this is 1. Plus, okay, 1/2 base 1 times height 2. So 1. Plus 2 times 2. Plus 1 times 1, and then this would be 1/2. Plus 1, this is 1, and then the area of this triangle is, so 1/2 base times height. So this is going to be 1, just like this. All right. So minus 1/2 plus 1/2 is 0. 1 plus 1 is 2. 2 plus 4 is 6. Plus 1 is 7. Plus 1 is 8. Okay. So, well, there we go. So F average is equal to 1 over B minus, yeah, it's this, right? We just calculated this. So what's 1 over B minus A? It's 1 over 8 times 8. 1. Let's see. I think I messed something up. 4, 5, 6, 7, 8, 9. So no, this is, yeah, 4, 5, 6, 7, 8, 9. So this is 9. This is 9. 1 over 8, so it's 9/8. In a certain city, the temperature in degrees Fahrenheit, T hours after 9 a.m. was modeled by this function. Find the average temperature during the period from 9 a.m. to 9 p.m. So you have a function that gives the temperature as a function of time in hours. And they're saying, so over this time interval from 9 a.m. to 9 p.m., what was the average temperature? So T is in hours. We're going from time T is equal to 0 at 9 a.m. to time T is equal to 12 at 9 p.m. So A is going to be equal to 0. B is going to be equal to 12. Again, because T is in hours. So T average is equal to, it's going to be 1 over 12, and then the integral from 0 to 12 of the function. 50 plus 14 sine pi t over 12 dt. So this is 1 over 12. And we've got 50t plus, so, okay, cosine, the derivative of cosine of t gives minus sine of t. Well, okay, we might as well do, let's do this. Let's just go ahead and separate this into separate intervals here. 50 dt plus 14 sine of pi t over 12 dt. So this is 1/12 50 times 12 plus 14 times, okay. The derivative of cosine t is minus sine t. The derivative of cosine of pi over 12t is minus sine pi over 12t times pi over 12. So we're going to need a minus 12 over pi and then cosine pi t over 12. Right? Because, okay, so take this derivative. Cosine of pi t over 12 is minus sine pi t over 12 times pi over 12. So you're left with just positive sine pi t over 12, evaluated from 0 to 12. Okay, so 1/12, 50 times 12 is 600, plus, so we can take out this minus 12 over pi. So in that case, we would have minus 168 over pi, and then, so cosine pi t over 12 from 0 to 12. So plugging in 12, that's cosine of pi is minus 1 minus cosine of 0. Okay, so 1/12, 600 minus 1 is minus 2, so 168 times 2 is 336. All right. So this is 600 plus 336 divided by pi divided by 12. Okay, and this is, so approximately 59 degrees Fahrenheit. Was the average temperature from 9 a.m. to 9 p.m. according to this temperature function. The velocity v of blood that flows in a blood vessel with radius r and length L at a distance r from the central axis is given by this function, where P is the pressure difference between the ends of the vessel and this N is the viscosity of the blood. Find the average velocity with respect to r over the interval from r is equal to 0 to capital R. Compare the average velocity with the maximum velocity. All right, so they're saying that you've got like a blood vessel here. You know, you're going from one end of a blood vessel to the other, and the velocity of the blood flow is a function of, like, so you have each cross section, and the velocity of the blood is a function of R. So like at the center, I think at the center it might be the largest velocity. Yeah, it should be, because R is equal to 0. At the center is where you have the maximum velocity. But they're saying, what's the average velocity? Like when you get to the walls, the blood sticks to the walls, so the velocity is 0. Because this is, capital R is the radius of the, let me redraw this. So this is zoomed in. Okay, so you've got this blood vessel here, a certain length of blood vessel, and the velocity of the blood is not a function of this direction. It's all you have the same velocity profile at any cross section, and the R is this, right? Just any radius between zero and this is capital R. Capital R is a constant. R is it's like the R is like the variable. When R is equal to capital R, the blood sticks to the walls, so the velocity is zero. And I believe when R is equal to zero, that's the maximum velocity. And we calculated this in a previous problem in chapter 3. We calculated the maximum velocity, and I'll go find what it is. And so, yeah, I just checked the maximum velocity, and we went through the whole process of finding the maximum value of the function. The maximum velocity was when this R is equal to zero. So V max was equal to P capital R squared over where this is L, the length of the blood vessel. Okay, P is the pressure difference between the ends of the vessel, and then this N here is the viscosity of the blood. All right, so it's saying calculate the average velocity with respect to R. So not the maximum velocity, but what's the average velocity over the cross section? How do you do that? Well, we're just going to find the average value of the function over the interval from 0 to capital R. So this is going to be 1 over capital R, and then from 0 to capital R of and dr, like that. Okay, so let's pull out constants. The L is constant, this viscosity is constant, the P is constant, the capital R is constant, but let's start with just, so for, okay, and then okay, so what we've got is so this is R squared R minus 1/3 R cubed. That's the antiderivative with respect to R, because R squared is capital R squared is a constant. So this is, okay, when lowercase r is equal to 0, this goes away, so we just need to plug in capital R, which is R cubed minus 1/3 R cubed, which is times 2R cubed, like that. And so this cancels. So you've got 6. Now I'm looking on Chegg, and it's saying that this is everything's right except instead of 6, this should be 4. So their answer is capital P, capital R squared over 4NL. Why do they say that? Oh, no, they don't say that. That's the maximum velocity. So this is the correct answer. The maximum velocity is over 4. So they differ. Comparing these two, they differ by a factor of, so what's 4 times what is equal to 6? 6 divided by 4 is 3/2. So if you multiply this by 3/2, you get the max. So the average, the maximum velocity is 1.5 times greater than the average. It seems kind of small, but interesting.